Hello, class. Dr. J here tonight. Um, I thought we would spend a few minutes here talking about a couple of the demonstration problems in Chapter 8 of your text that I think are very similar to the two or three hardest problems on your exam number two. I think for the most part, exam two should be very doable for everybody. I think the whole thing should be actually, but alas, I know there's a little bit of math anxiety, if you will. I've been catching a little bit of vibes, not much in that respect. You got to realize, I guess, our we have a large class actually with all the online students, and students come from many directions. So some have a little more mathematical comfort than others, and so forth. And so, what I've tried to challenge you to do in this course is to learn a little basic, just basic differential calculus back there. You may want to go back and review the primers that I've put up online, the videos and so forth. But as far as basic algebra, just very basic differential calculus, because alas, when there's certain fields of study where a little mathematical analysis is unavoidable, and certainly economics is one of those. Okay, and so I can't really make any apologies for that. It's just the nature of the beast. And so, at any rate, I've tried to keep this to a minimum. But what I'm attempting to do tonight is look at what I think are the most mathematically challenging couple of problems on the test. The test is pretty much multiple choice, pretty much all multiple choice. I won't say it's all multiple choice, but mostly multiple choice. Um, you need though to be able to do a little problem solving. There's just a few problems where you can't exactly look at the selections and decide which one is the appropriate A, B, C, or D answer to give. So, so at any rate, these demonstration problems, uh, 5 and 6 in your text, are again very similar to what I think you will consider at any rate to be the hardest problems in on the test. So hopefully you can see this with me here. I thought we would work these together. Let's see here if I can get a little different fix on this. Okay, so this is demonstration problem 8-5. By the way, I would just say that, chapter 8 to me is a capstone chapter in this course. We haven't had opportunity to go in very much depth with a number of topics we've looked at. I would have liked to have spent more time doing linear regression, say, and perhaps the next time I teach this course, this is the first time I've taught it in many years, many years. But the next time I teach it, I'll probably expect my class to do a little bit more in the way of linear regression and defining a demand function and so forth, doing a little bit of math modeling. But in an 8-week session, as we've had, and with limited contact and so forth, that hasn't really been achievable this time. But that's one area, along with kind of the area we look at in these demonstration problems 5 and 6, that I think are kind of summative, capstone kind of ideas. And by that, what I mean is you're looking at real world problems that justify why we've gone through some of the study, uh, some of the basic mathematics, if you will, and so forth that we have to this point. Uh, so we can talk about supply and demand curves and all that, but marginal revenue, marginal cost curves, and so forth. But it is really pointless to do so unless you bring them all together into a single problem that kind of illustrates why in the world we would want to do this stuff to begin with. So, demonstration problem 5 and 6 are two such problems that hopefully will give you some appreciation for why we've gone down this journey of 8 chapters in this book by Baye. And you just kind of get a basic flavor of what microeconomics is and managerial economics, but micro in particular, that part of managerial is used for in the real world. So without any further ado, I'd just say that this problem, and again, 8-6 are two such problems that I think we can look at together and see why we're doing this stuff. So here we're talking about a monopolist, okay? And it says a monopolist analytics team has estimated its demand function to be this. Now you should recognize that this is a downward sloping demand function because it has a slope of a -2. And so when we talk about this being the demand function for a monopolist, really for any producer, then remember that we then can assume the marginal revenue function is a function of has the same vertical intercept except twice the slope. So the slope here is -2 for the demand function. Correspondingly, the slope of the marginal revenue is -4. What am I saying is this? If we just kind of rough out this a diagram here, we sketched a demand function which looks like this. It would have a vertical intercept of 100, has a slope of a -2. Then from the other videos and things that we've looked at, remember that if this is the demand function here, I'll just say demand, then the marginal revenue curve is twice as steep, right? So, I mean, if this is P equals 100 minus 2Q, then this would have to be P equals, or marginal revenue equals 100 minus 4Q. So you just double the slope, okay? And so this is half of what you need to determine the profit maximizing output. In any market structure, you got to know marginal revenue to get the profit maximizing output, and then you need the marginal cost. So they're going to want us to determine the profit maximizing price and quantity. So we come up here to the cost function. C sub Q is 10 plus 2Q, okay? And so the marginal cost is the derivative of the cost function. So this would be simply 2. So you differentiate this. If this were an x here, you know what dy dx is. It would be 2 and so forth. So the marginal cost is 2. So we have a marginal revenue and a marginal cost. And so the marginal cost is simply this horizontal line here. You know, it's usually in the real world kind of an upward sloping U-shaped curve, but we're making things simple here. And so we got a cost function that gives us this nice linear horizontal marginal cost curve. Marginal cost is equal to 2. Now, before I go on and actually work this problem in more detail, I will say that, I mean, I guess your book may find the marginal revenue a little different way. Let me just say here that, and we'll look at that here in a second, just say that for a linear demand curve, as I show on some of the videos, especially the videos from my principles level courses, I show how the marginal revenue has the same vertical intercept, but just simply twice the slope. So, but if it, another way of looking at this, just so that you'll see the consistency here, is that another way of getting the marginal revenue, the way they show you, and I want you to be able to read their solution, right? Okay, so what are they saying? Well, another way of looking at this, and the answer there, is that if you got the price given here on the left, then another way of getting the marginal revenue is to note that revenue is equal to price times quantity, right? Price times quantity is revenue. So if I multiply through by Q, I'd get the revenue function. So this is minus 2Q squared. Okay, so this times Q and this times Q. There's the revenue. And if that's the case, the marginal revenue is the derivative of the revenue function, if you will. You can write this if you want, with respect to Q. So you know how to differentiate a simple polynomial function. If this were an x, it wouldn't be any different, but perhaps that's easier for you. The derivative of 100x is 100, okay? And then the derivative of minus 2x squared would be minus 4x. Okay, so this would be the marginal revenue if you find the revenue function first. Okay, you still get, okay, marginal revenue is equal to 100 minus 4Q, or let me make this a Q here. Okay, I just said X because I was trying to show you the similarity. But the point here is, however you do it, you should, I would say in general, you should be able to find a marginal revenue and marginal cost function these ways, okay? Because you may not necessarily have a linear demand curve or what have you. So the marginal revenue is the derivative of the revenue function. How do you get the revenue? You take the demand function, multiply through by Q. Okay, so when you do that, you get this thing here. That gets you the revenue function, take the derivative. Similarly, the cost function here, I just said it's 2, but what is the cost function? The cost function is the derivative with respect to Q of C sub Q, okay, of the cost function. And so that's the sort of things that they're writing here, okay? That they wrote marginal cost is 2 here. Marginal revenue, notice what is this here? This is 100 minus 2 times 2. Well, that's minus 4Q, okay? What they're doing is they're bringing the Q squared exponent down front, as I've taught you how to do this. When you take the derivative before, bring this down front. So minus 2 times 2Q to the first power. Of course, that's a minus 4Q. But they left it kind of factored form here, just so you know where that came from. So again, this is the marginal revenue, and this is the marginal cost. So I hope you've already spent some time reading this problem and studying it. Sometimes I can't take these things for granted, I suppose. I don't know why, but when I was a student, certainly I would read my book, and if I came across something like this, I'd work through it, okay? And I expect you to do no less, really, okay? Uh, you should have already tried to have worked through this. If you haven't by now, then that's not good, okay? It's not really my fault if you haven't. You need everyone should be proactive here. Since chapter 8 was assigned some time back, I know this is a compressed term, but hopefully you've already read down to this. And if you can get these two things here, just using the basic calculus that we just looked at, you could follow these two ideas down further, and you get the profit maximizing price and quantity, okay? Price and quantity here, and then the profit maximizing revenue. So, I mean, we can do that here. I guess I can ink this out real quick. Okay. Find the profit maximizing price and quantity, but we're going to get these same things here. But so what do we mean here with profit maximizing price and quantity? The profit maximizing quantity is this Q star, if you will. That's the intersection, the marginal revenue and the marginal cost. And then we'll look up here on the demand curve to get the profit maximizing price. So that's what we're out to find here in this particular problem. Okay, hope that makes sense. So let's find Q star first by equating these two things right here. Okay, so marginal revenue equals marginal cost. Like I've said before, that's the most important equation in microeconomic theory. So I equate marginal revenue and marginal cost here. So I'll bring my numbers to the left and my quantity, my variables to the right. Q is 98 over 4, which I think is 24.5. Okay, so this is 24.5 units. So that's what this is. This is 24.5. Okay, that's where it is on the graph. That would have been nice if they'd have shown you this graph, but they didn't. So there it is. Okay, so once you get the graph, I think in your mind, you kind of have a roadmap for yourself. So how do you get the price that corresponds with this? What should the monopolist charge to sell 24.5 units? Well, use now the demand curve. Okay, P equals 100 minus 2Q. So this is Q star. P star is 100 minus 2 times Q star. Okay, which is 100 minus 2 times 24.5, if you will, okay, 24.5. So when you do that, you get 51, I believe. So $51 is the profit maximizing price, okay? So what's a profit maximizing revenue? If you got the revenue and you got the cost, you get the profit. So let's just skip down and get profit. pi is profit. Profit is P star, Q star. They got an M here, monopoly, what have you. But this is the profit maximizing price and quantity minus the cost evaluated at Q star. Okay. So P star is 51.00 times Q star is 24.5, 24.5. And then you subtract from this the cost function. The cost function's up here, 10 plus 2Q. So we're going to subtract 10 plus 2 times Q star, which is 24.5. Okay. So once you do that, you get $1,190.50. There's the profit maximizing. It's the maximum profit. Do we care about that in the real world? Do you care what your profits are going to be? I hope so. If you're working for somebody, I'll guarantee your employer does. And so if you're going to use your MBA to any effect really in the world, you need to be able to solve a problem like this. Sometimes we'll have estimates for demand curves and so forth, cost functions. These are things we can arrive at by looking at our manufacturing process. Say if we're manufacturing, that's a fixed cost, what you rent every month. Maybe it's $10,000 a month. Okay. Whatever units of we're in, we would just say $10 though. It's the same principle plus 2. This would be the cost per unit. Think about this a second. If you make chairs, this is $2 a chair. That's what it costs, is a variable cost to making a chair. Each chair has direct materials, direct labor, and some variable overhead involved in that at a rate of $2. Okay, so you got $2 times the number of units plus your fixed cost. That gives you your total cost. I hope that makes sense. I mean, it's very, 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 very real world. And over here, the demand function, we can do some market studies and get this, and we realize that though that if we lower our price $2 a unit, then we can sell more units. So you always have a negative slope here. So at any rate, this can be obtained by some market study and so forth. This linear demand curve, 100 minus 2Q, will tell you how many units you can sell as a function of the price. So if you lower the price, you can sell more units. These have opposite, Q and P have opposite signs on them. So if you want to sell more units, you got to lower your price. And that's a real world constraint for a monopolist. You notice your problem says this is a monopolist. In perfect competition, again, recall that you wouldn't have this part here. Perfect competition faces a demand curve, an individual demand curve. The demand facing an individual supplier is a fixed price. Okay, so you wouldn't have this term. It becomes even simpler here. Okay, and the price though equals the marginal revenue. Okay, you can go through the calculus and get the same thing. So if this were a perfectly competitive situation, we'd set the marginal revenue, which would be a constant equal to the marginal cost, which probably would have a variable in it here in a real world problem. So at any rate, hopefully you've already done some of those. There's some of those kind of problems, even on the principles level videos that I've provided. So this is demonstration problem 8-5, tells how a monopolist would obtain the profit maximizing output down here, output and price, and what the profit maximization would actually be here at the bottom. So that is problem 8-5. All right, now let's look at problem 8-6. Okay, I've written a little here on my book. It's okay here. Just want to say here that your book in the reading, hopefully, again, you've read this chapter, but you'll read a little background here about multi-plant firms and determining the level of output, profit maximizing output for a multi-plant firm. And the deal is, a lot of times when you have a multi-plant firm, the individual plants are using different levels of technology. One plant may be older than another plant. and so forth. So it may be more costly to produce in one plant than in another. That's kind of the situation we have here. They tell you that in demonstration problem 8-6 that you have an inverse demand. When we say inverse demand, we're simply solving for P in terms of Q, whereas a demand curve has Q in terms of P. Remember the independent variables on the vertical axis of economics. But again, a lot of times we use these terms interchangeably. We'll say demand when we mean actually inverse demand. But the inverse demand function here is P equals 70 minus 0.5 Q. It's kind of hard to see here, I think. Let me see if I can get a little better picture. That's a little better, isn't it? Okay, I think that is a lot better. Okay, hopefully I just have to keep this thing ratcheted down. Hopefully that's a little better. So this is the inverse demand function. Then they give you have two plants. So they give you the marginal cost of each plant. Plant one, okay, marginal cost of plant number one is 3Q1, okay, and marginal cost of plant number two is just simply Q2. So these are the outputs of the two plants respectively, okay. So what they ask us to do here is how much output should be produced in each plant to maximize profits, and what price should be charged for the product. So we're going to use, again, this all-important function here, or relationship, if you will, to find profit maximizing output. Okay, define the profit max output, which we'll call Q. By the way, Q is the output of the two plants added together. That's a total output. Then we have to solve this relationship again. Marginal revenue equals marginal cost. Okay, so you have to do that for each plant, really. Okay, so we need first off solve this for each plant. Okay, for each plant. So okay, so what we're going to have, I guess I could say for each plant, I equal 1 and 2. There's two plants. But at any rate, first off, let's find the marginal revenue function. Again, you can use calculus to do that. You can take the price function here, the demand function, 70 minus 0.5 Q. P equals 70 minus 0.5 Q. And since this is a downward sloping linear demand curve, you see the marginal revenue is going to be 70 minus double this, so 70 minus Q. But just show you where the calculus comes in if you want. Let's see here. Let's say revenue then, sorry about this, is found by multiplying through by Q. So this is 70Q minus 0.50 Q squared, okay? All right, so just multiply by that. And so marginal revenue is 70. Okay, so remember the exponent comes down front, you knock the exponent down by 1. So it's 70 minus 2 times 0.5. Well, that's 1.0 times Q. Okay, bring this down front, 2 times 0.5 is that. So 70 minus Q, okay, is the marginal revenue. Or if you have output from the two firms, this would be 70 minus Q1 plus Q2, because this quantity here, the output from the two firms is equal to Q. Okay, and we want to find the output from each firm. So the total here would be the output from the two, Q1 plus Q2. So marginal revenue, so that's the left-hand side of this for I equals 1 and 2. So I want to put a little I here. So we're going to do this for plant 1 and plant 2. All right, so we're going to have marginal revenue here is equal to the marginal cost from plant 1. We're going to have marginal revenue equals the marginal cost from plant 2. And here is your marginal revenue function, if you will. They stacked this vertically in your book, but that's okay. 70 minus Q1 plus Q2 is marginal revenue over here. It's also marginal revenue over here. 70 minus Q1 plus Q2. Okay. And then we set this equal to the marginal cost. And we have the marginal cost given up here, 3Q1 and Q2. So I'm just going to put a 3Q1 and a Q2 here. Okay, so you have two equations and two unknowns. So you have to solve each of these for Q1 and Q2 respectively. So it shouldn't be difficult to do here. That's what they show you how to do that in your text. So for instance, from the first equation, this is 70 minus Q1 minus Q2 equals 3Q1. And I can solve for Q2. Let's bring Q2 to the right, get our variables away from each other. So the 70 minus 4Q1. So here's one equation and two unknowns. I guess they got that for you here, right? They just have it flipped, but it's no big deal. And then the second, we can substitute that. Okay, we can substitute that in for Q2 in the second equation if we want. So everywhere you have a Q2, let's substitute. If we call this equation 1, there's a lot of different ways of doing this. Don't get hung up, oh, I got to do it this way or that way. It doesn't really matter. There's different ways. You could have solved this for Q1, substituted over here. Or solve this one for Q1 and substitute it over here. You got to have eliminated a variable. So what I've done here is when I've solved for Q2 in terms of Q1, and everywhere I have a Q2 over here in equation 2, if I put this expression in the left, then I have one equation and one unknown. So I'm going to substitute this into equation 2. So everywhere I have a Q2 in the second equation, I'm going to substitute the left-hand side of the first equation. So this is 70 minus, Q1, all right, plus Q2. Well, what's Q2? Well, Q2 is this, 70 minus 4Q1, okay, equals Q2. What's Q2 again? It's 70 minus 4Q1. I think they have something like that for you in your text here. And they go on down, they solve for Q1 and Q2. So if you solve this for Q1, you're going to get Q1 is equal to, I believe, 30. This is Q1. And then take this and put it here into either of the first two equations. Whoops, I'm sorry. Q1 is 10. I'm sorry. It shouldn't be difficult to do. I just looked at the wrong number. You'll see it right. Where is that? Right here. Q1 is 10. Substitute that back into this equation here that gives you Q2 in terms of Q1. So Q2 is 70 minus 4 times 10. So Q2 is 30. So here's Q2. Q2 is equal to 30. Okay, so you want to produce 10 units in the first plant, and you want to produce 30 units in the second plant, okay? And then you can find out what the price has got to be, because this is a total of 40 units, right? 40 units. So what price are they going to charge for their output? They're making these chairs. It's identical chairs, but in two different plants. So whatever it is. So they're going to make 10 in one plant and 30 in the newer plant, say, what have you. But they're going to charge the same for all of them. All you have to do is use the demand curve way back here at the top. 70 minus 0.5 Q to find out what the price is. So this is going to be 70 minus 0.5 Q, but now Q is 10 plus 30, which is 40, and half of 40 is 20, and 70 minus 20 is 50. So they're going to charge $50 a chair, okay? $50 a chair. They're going to sell then 40 chairs, 10 of which comes from the first plant, and 30 comes from the second. So there's a number of questions you could ask here, okay? What's the profit maximizing price? What's the profit maximizing total output? What's the profit maximizing output from each plant? And then I could also ask, what's the maximum profit? Should be able to do that. This is the price, and you got the quantity, okay? And so you should be able to find the revenue and subtract the cost, kind of like we did in the previous problem. Revenue is easy. It's the price times the total quantity. It'd be 50 times 40. Sounds like 2,000, 50 times 40, isn't that $2,000? That'd give you the total revenue. So find the total cost by substituting 10 and 30 respectively into the cost functions if that were given. I guess they didn't give us that here, so they didn't give us the total cost. So I couldn't, in this problem, you'd have to have a little more information to find the maximum profit, wouldn't you? Because they gave us the marginal cost. If you had the cost functions given, you could find the marginal cost easily enough by differentiating those. In which case you could find the maximum profit as we did in demonstration problem 8-5. So anyway, let me back off of that just a little bit. I know there's a lot there. It's kind of hard for me to show you all this, but there's the heart of the problem right there. Okay, to find the profit maximizing output, we set marginal revenue equals marginal cost for each of the two plants. There we go. Okay. At any rate, there's nothing here that's not in your book. Okay. I just thought it was worth us walking through this together. So at any rate, Dr. J is here to help you as I can. I realize we're not quite, but getting close to the eve of your final exam. Hopefully you've already wrestled with these two problems. If you're too busy to do that, then I don't know what to say and so forth. I want everyone to do well. Dr. J's got a big smile on his face because he wants you to do well, and he's hopeful that you will. So I'm being a little silly here, but at any rate, sometimes I get that way. But work hard at this. Continue to work hard. If you got any questions between now and the test, let me know. I plan to be on campus Wednesday night from 7 to 8:15, I guess it is, kind of the appointed time that I meet with one of the sections. If you happen to have any questions, whoever you are may be in the class, feel free to come see me at that time, and we can discuss this. So without any further ado, I wish you well in your continued studies in preparation for the final, and stay in touch, and I wish you well. Have a good evening. Bye-bye.